Hi, my name is Chris Pillion, and this is my final project for CSCI 5239 Advanced Computer Graphics. For my final project, I decided to make a terrain, something that you might see in, say, a video game or some sort of large-scale scene. I wanted to generate a large terrain in kind of an optimal way, and so I figured this was a large-scale project where I could incorporate a lot of the ideas that we went over in class, and I thought it would be a good challenge, and it was also something I could build upon in the future if I wanted to continue to make something more complex. Um, so I guess I'll start out by just showing you kind of my application, my scene. So we'll go ahead and launch that. So you can see it here. I have different fragment shaders. I'll kind of go over each one. I just have this height gradient right now, but you can see the basic scene right now. So the big thing in this project was actually the terrain object, obviously, and that object uses 5 stages or 5 different shaders, one for each different stage down the programmable pipeline. And so you can see this terrain is actually tessellated, and I'll go over the code later, but the idea is that when you get closer to the terrain, you can see we get a larger number of triangles, a higher fidelity level of detail, and as you zoom out, those triangles get bigger and bigger, so you're not wasting the resources to have a very fine mesh of triangles all over the scene when way out here you don't need that level of detail. So like I mentioned, this is the height gradient. So the terrain is basically just shaded based off height, and so you can see the lower areas are green, the higher are white. I also have just a simple wireframe which shows the same thing. As you approach them, you get more and more triangles, etc. I have just simple textures applied, so you can see the high points are white for the snow, and then the rock and the grass are based upon normal and stuff. So if you change the peak size, you can see everything's just grass if it's all flat, and if you start raising it, it starts taking the normal into account or the height into account and shading it depending on kind of the features there. I also have lighting. So so you can see the lighting calculations there. If we expand this map a little bit, it comes out a little better. And then I just combine everything there. So yeah, that's kind of the idea of my project. And again, you can kind of play with this and see how it dynamically changes the terrain. So I'll go over a little bit of code now. So my whole project was done using modern OpenGL, so it's using version 4.1. And so you got to explicitly define that when you create your application. And then we go ahead and we create a new window, which is pretty familiar to a lot of our homeworks. You can see here, this format's pretty simple. It's just defining the options on the Qt widget and everything like that, and actually making a instance of the OpenGL widget where we'll actually draw things. So I won't spend too much time here. OGL widget, OpenGL widget is what actually draws a scene. I'll go over the important things. Here we load all our different shaders for the different objects in our scene. And then we go ahead and load textures. One unique texture I used a cube map. So that's 6 different images seen here. So I used the cube map to make my skybox. So you load the 6 images, and then you actually map each image to a different face of the cube map, and it's all stored in one texture. So when I draw my skybox, it's basically just a giant cube, and you apply that texture, it knows what face to put the textures on and how to do the lookup or the sampling of that texture. And the sampling's done through its own shader. where you use a specific cube map sampler. And then we load the other textures. To actually get the heights of the terrain, I use a height map. So it's basically just a grayscale image. And you sample that image and it pulls the RGB value at that pixel, and then it uses that value to determine how high or to displace the vertice of on the height map. So that's how you kind of get the different heights quickly across the scene. And then again, because we're using modern OpenGL, everything needs to be stored in a vertex buffer object and a vertex array object. So I'm not going to go over each one of these, but down here I actually have the terrain vertex array object. So we create the vertex array object, then we go ahead and we generate all the vertices we want in here, and we store them into a vertex buffer object. And once we have that vertex buffer object, we can define what data is in there. So here I'm just defining the XZ points because the shader does the actual vertical displacement of the vertice. So we just say enable this vertex attribute only has 2 values for each one, an offset of 2, etc. So then we actually paint the scene. I won't spend too much time on here. The only unique thing here is the skybox. We draw the skybox first with the depth mask disabled. That way everything's always drawn in front of the skybox, and it kind of looks like it's always in the distance, making your scene look a lot more vast than it really is. And the other thing we do is we disable the translation components of the model view matrix. That way it's always, your camera is always centered right at the center of the skybox, and it always looks like it's the far horizon. It's not very close to you or anything, or you can never approach the wall of the skybox cube. So I won't spend time on a lot of this. It's basically just drawing the scene and setting the uniform values for the shaders. If we go to the shaders, the one I wanted to focus on is the terrain tessellation, because that's the biggest one. So the vertex shader is just pass through. It just takes the vertices you define and passes them to the tessellation control shader, which is this guy. Here we're just we're defining each patch to only be one vertice that we have. And so because we're using tessellation, we need to use the primitive patches. So we say each vertice is going to be a patch, and that patch is then extruded into a square between each of the vertices. So we have we ultimately come up with a square patch. And then once we have that patch, we determine the tessellation level by using something called the sphere method, which actually takes the distance or the diameter of a sphere that's projected, and we take that distance and we project it onto our screen, and that kind of determines the tessellation level. If you want to know more about that, there's a great white paper by NVIDIA using DirectX for terrain tessellation. It's pretty interesting. So that's how the dynamic tessellation level gets performed, and that's why you get more triangles when you're up close and less when you're far away. That all gets passed to the tessellation and evaluations shader, which actually creates the vertices. Now that you have the factor of tessellation, we actually create the vertices through this. This is where your height map comes into play and how it's actually vertically displaced and everything. In here we also calculate the normal for our lighting calculations. The lighting's not actually done in this stage, it's done in the fragment shader, but this actually stores the normal, so you can use the normal in your Phong lighting calculation. And then I also have a geometry shader in here, which actually does the wireframe stuff. So you can see we're creating a triangle, and we're using 3 vertices to do that. So it's actually outlining the triangles we need on our tessellation, and that helps give a nice visual representation of how the tessellation is working. And lastly, we have our fragment shader. So I went over the different fragment shader types when I displayed the program. But basically in here we have our lighting calculation, our wireframe model, kind of how we wanted to color that, and then the different combinations of options that we had. And then in here, just the main program checks what mode you have defined and shades it appropriately. So it looks like I'm a little bit past 10 minutes, so I don't have a lot more time. But again, here's the scene. If you look around, you can see the skybox, how it's doing the sampling. There's a lot of different other different shaders in here, but for different objects. But I think the big one was the terrain and how that works, and I think that's the biggest part in time, or biggest part of the project that I put the most time into. So glad we got to go over that. Anyway, that's all I have, and thanks for listening. Take care.